Hello everyone, welcome to the class of Introduction to Finance. Today let's continue with Chapter 6. This is our second class of Chapter 6 and we're going to finish the rest of the Chapter 6 today. So let's continue. In the previous class we discussed the factors or the determinants of the interest rate, and then we discussed what is yield curve and term structure. So in this class, we're going to discuss in detail how to calculate the appropriate interest rate level and how to calculate each risk premium so that you can calculate the final interest rate. And after that, we're going to discuss the pure expectation theory. So how to calculate the future interest rate based on the information you have. So that's basically the two goals in today. Let's start with the calculations of each risk premium. So the first one, we can go back and you can have a look. Remember the equation that we discussed last time. This one. So R equal to R star represent the real risk-free rate of interest, and then IP is the inflation premium, DRP is the default risk premium, LP is the liquidity premium, and MRP is the maturity risk premium. So basically in all these factors, the default risk premium and liquidity premium, these two are usually we won't ask you to. And it's a typical question you would see in the quiz or at the homework, where we ask you to calculate the yield for different types of securities. Like the first two are treasury securities but with different maturities, and the last one is a corporate bond but with the same maturity as the treasury bond. So this is a typical question. Means that I'll give you all the information for the other 5 factors, starting from the real risk-free rate of interest to the inflation premium, default risk premium, liquidity premium, and maturity risk premium. And I ask you to calculate the yield, the required rate of return. So you just need to use that equation. So this is a typical question like that. But there will be questions similar to this, but you will have to calculate backward. Means that I tell you the yield of different securities and I ask you to calculate one of those factors or risk premiums in the equation. But I'll show you an example of that later. So let's first have a look at this question. It says an analyst evaluating securities has obtained the following information. The real rate of interest is 2%. So this is R star, right? And it is expected to remain constant for the next 3 years. Means that this R star doesn't change at least in the next 3 years. And then inflation is expected to be 3% next year, 3.5% the following year, and 4% the third year. Right? So these are the inflation rate in the next 3 years. And then the maturity risk premium is estimated to be maturity risk premium equal to 0.1% times t minus 1, where t is the number of years to maturity. The liquidity premium on relevant 3-year security is 0.25%, and the default risk premium on the relevant 3-year security is 0.6%. Yeah, so this is LP, liquidity premium, and this one's the DRP, default risk premium, right? So if we write down that equation, basically you know everything about, you already have everything you need to know about those 5 factors, right? The first one is R star, which is real rate of interest. Second one is inflation, so you already know the inflation rate for the next 3 years, just depending on how long is the maturity of the security, then you can calculate the inflation premium accordingly, right? So let's have a look at the first one. It asks what is the yield on the 1-year treasury bill. Yeah, 1-year treasury bill, remember this is 1 year, means that there's no maturity risk premium, right? Because it's short term. And even if you use this equation, it's still 0. because t equal to 1, so this whole thing equal to 0. And moreover, it's treasury bill, so there's no default risk premium and liquidity premium, right? So these two, you don't have to add it in. So basically, there are only three factors left: real risk rate of interest, plus inflation premium, and then plus the maturity risk premium. But maturity risk premium is also 0, so basically only two left, which is the real risk-free rate of return 2% and the inflation premium. Because it's 1 year, so you only need to consider the inflation in the next year, which is 3%. So that means it's 2% plus 3% equals to 5%. So that is the yield on this 1 year treasury bill. What about the yield on the 3-year treasury bond? So this 3-year treasury bond, first you have to calculate inflation premium. Inflation premium is the average of these three inflation rates in the next 3 years, right? So 3% plus 3.5% plus 4% divided by 3, right? And then the average should be 3.5%. So that's inflation premium. And more, again, this is the treasury bond. So again, you no longer need to consider the liquidity premium and default risk premium. All you need to consider this case is the, apart from the two real risk-free rate of interest and inflation premium, the other thing you need to consider in this case for the 3-year treasury bond is the MRP, maturity risk premium. Here t equal to 3, so MRP will be equal to 0.2%. So it means that it's 2% plus the 3.5% inflation premium plus the 0.2%. So that would be 5.7%, right? Yeah, you see here, it's 5.7%. The first question is 5% because maturity risk premium is 0, so it's not there. You only need to consider 2% plus 3% equal to 5%. For the 3-year treasury bond, you have to consider the maturity risk premium, which is 0.2%, and the inflation premium is the average of the inflation in the next 3 years, so it's 3.5%, right? And then the last one is the yield. What is the yield on the 3-year corporate bond? Remember, the corporate bond is also 3-year maturity, means that it has the same inflation premium as this 3-year treasury bond. So maturity risk premium is also the same because they have the same maturity, and real risk-free rate of return is the same for everybody, 2%. So the only difference between this 3-year treasury bond and 3-year corporate bond is the default risk premium and liquidity premium, right? So basically, what you can do is that you just use the answer from the second question plus these two, and then you will get the final answer, which is 5.7% plus 0.6% plus 0.25%. Then you will get 6.55%. So this is the exercise question. Then another exercise question: which of the following statement is correct? You can pause here and read through all these options and then think about it before you play, and we discuss which one is the following statement, which of the following statement is correct. Okay, suppose you have finished reading all the options and you already have an answer, so we can do it together. A says the yield on the 3-year treasury bond cannot exceed the yield on the 10-year treasury bond. The good thing is that they are all treasury bonds, so you don't need to consider the default risk premium or liquidity premium, right? Then, and they all have the same real rate of return. So the two differences between these two bonds is the maturity risk premium and inflation premium, right? Clearly, the 10-year treasury bond is going to have a higher maturity risk premium because it has some longer maturity. But we don't know whether the 3-year treasury bond will have a higher inflation premium than the 10-year treasury bond or not, because it's an average of the inflation rate in the maturity before it expires, right? So if inflation in the next 3 years is high and expected to go down after the next 3 years, then in this case, the inflation premium can be very high for this 3-year treasury bond, even higher than the 10-year treasury bond. While the 10-year treasury bond definitely has a higher maturity risk premium, but it's hard to say whether it can cancel out the effect from the inflation premium, right? So the fact that it's uncertain, the inflation premium, we don't know which one is higher and by how much, like if it's higher, by how much. Therefore, it's very hard to compare these two with different maturities. Basically, whenever you see securities with two with two different maturities, just count them like not comparable at all, because you not only need to consider the maturity risk premium, which is comparable, at least it's linear to the maturity, but the inflation premium is the one that is very hard to compare, because you don't know about the inflation in the next few years. So basically, A, we don't know, we can't compare. C is the same problem. Yes, they are both corporate bonds, but they have different maturities. Therefore, the mixture of the combined effect of the inflation premium and the maturity risk premium made it very hard to compare. Therefore, C, again, we don't know. The same problem with D. Yes, it's the same bond, AAA rated corporate bond, but they have different maturities. Therefore, again, we can't say. We don't know which one will have a higher yield. So the only thing then that basically we rule out A, C, D, right? So B says the yield on the 2-year corporate bond should always exceed the yield on the 2-year treasury bond. Okay, in this case they are the same maturity, but they are different types of bonds. In this case, can we compare them? The answer is yes, because the difference between these two is the default risk premium and liquidity premium, right? So if it's corporate bond of different credit ratings, then in this case it's still a bit hard to compare, because yes, with the credit ratings I know which one has a higher default risk, but I really don't know which one has the higher liquidity risk. So it's hard to compare. But if it's between corporate and treasury, then in this case it's relatively easy, because there's no default risk or liquidity risk for the treasury bond, but there's definitely, or at least positive liquidity risk and default risk premium for the corporate bond. So in this case, no matter how little the liquidity risk and default risk premium is for the corporate bond, it will always be lower than it will always be higher than the treasury bond. So in this case, B seems to be correct. Then let's have a look at E. E says the following represents a possible reasonable formula for the maturity risk premium on bond, which says MRP equal to minus 0.1% times T, where T is the year to maturity. This one doesn't sound reasonable, because here it's negative, means that the longer the maturity, the lower the maturity risk premium, and it's even negative, which doesn't make sense. If you remove the negative sign, yes, this is a possibly reasonable formula. Even if you don't minus 1, it's still reasonable. But negative, no, it's not reasonable. So E is incorrect. The answer is B. Another exercise question. This one, before we read the whole question, I always my habit is always first look for the question, what does the question asks you, and then after you know what the question asks for, then you can go back and read this question. So this one says, what is the expected rate of inflation over the next 10 years? So this one is asking for the inflation, the expected rate of inflation over the next 10 years. So basically it's asking for inflation premium, right? And then that means we have to use, if we use that equation, we have to know all the other factors and the required rate of return. Then we can calculate the inflation premium backward, right? So let's have a look at the question together. Suppose the yield on the 10-year Treasury bond is currently 5.05%, and that on the 10-year Treasury inflation protected security is 1.8%. Suppose further the maturity risk premium on the 10-year Treasury bond is 0.9%, that no maturity risk premium is required on the TIPS, the Treasury inflation protected security, and that no liquidity premium is required on any Treasury bond. So given this information, what is the expected rate of inflation over the next 10 years? So basically, the information you have right now is for this for these two securities, right? A 10-year Treasury bond and a 10-year TIPS, the inflation protected security. Yeah. So that means that let's first use this Treasury bond. Here it says that the MRP is 0.9%, right? So that's MRP for this one. Remember, there are three factors in this 10-year Treasury bond. So the first one is the real risk-free rate of return, and then plus inflation, then plus the maturity risk premium, right? The inflation premium is clearly what we want to know, right? We want to calculate the inflation premium in the next 10 years, so we can leave it out. Then in order to know this inflation premium, the only thing that we need to, the only thing that is left out is the real risk rate of return. But here it didn't say anything about real risk rate of return, right? The only thing we know is this one. The 10-year Treasury inflation protected security is 1.8%. But remember, here it says inflation protected, right? So it means that this one doesn't have to consider the inflation premium, right? And again, it's Treasury security. So therefore, this 1.8% basically is just the real risk rate of return. Why is it just the real risk rate of return? Because clearly this is a 10-year Treasury inflation protected security, right? So even if you don't consider inflation premium because it's inflation protected, at least you should consider the MRP, right? Maturity risk premium. Then you have to read the question carefully. Here it says no maturity risk premium is required on the TIPS. So basically that means this 1.8% is just the real risk rate of return, the R star. There's nothing else included in this 1.8%. So basically that means this we now know all the factors that we need to calculate the inflation premium. So we can rewrite this equation like 5.05% equal to the real risk-free rate of return, which is 1.8%, plus the inflation premium, that's the one that we need to calculate, plus 0.9%, right? So basically, then in order to calculate this inflation premium, we just need to use 5.05 minus 1.8 minus 0.9. Then the answer should be 2.35%. So C is the correct answer. Then this is actually what we discussed before, the relationship between Treasury yield curve and yield curves for corporate issues. So the corporate and Treasury, right? Corporate yield curves are higher than that of Treasury securities because of the liquidity risk premium and default risk premium. Although not necessarily parallel to the Treasury curve. The spread between the corporate and Treasury yield curves widens as the corporate bond rating decreases, right? If the rating decreases means that they have higher default risk, right? So therefore, the default risk premium will increase if the bond rating decreases. Since corporate yields include a default risk premium and a liquidity premium, the corporate bond yield's spread can be calculated as this one. So the corporate bond yield spread will be equal to corporate bond yield minus treasury bond yield, which equals to the default risk premium plus the liquidity risk premium. So this is the corporate bond yield spread. And this one shows you using a graph, shows you the relationship between corporate and treasury yield curves. So the lowest one is the treasury bond, the middle one is a AA rated bond, and the top one is the BBB rated bond. So clearly you see that the treasury bond pays the lowest interest rate because they have no default risk, right? And then the AAA has higher credit rating, so it has lower default risk. That's why they also pay lower interest compared to the BBB rated bond. And this curve is basically based on the table here. So for different maturities, they have different interest rate, and then you just need to mark the dots and then connect them. Then you get this yield curve for different types of bond. Okay, now we have finished the equations of the determinants of interest rate. So the next is the second important topic in this chapter, that is pure expectation theory. So the pure expectation theory contains that the shape of the yield curve depends on the investor's expectations about future interest rates. Yeah, so basically it says the shape of the yield curve, whether it's going upward or downward or hump shape, that depends on the investor's expectation about future interest rates, right? So if investors expect that in the future the interest rate is going up, therefore you observe an upward sloping yield curve, which is the norm, right? But if the investors believe that the interest rate right now is already too high, in the future it's going to go down, then that means you're going to observe a downward sloping yield curve, right? So in that case, it's an abnormal yield curve. So if interest rates are expected to increase, then long-term rates will be higher than short-term rates, and vice versa. Thus, the yield curve can slope up, slope down, or even bow. Assumptions for the pure expectations is that assume that the maturity risk premium for treasury securities is 0. Yeah, so this is the first expectation. And then long-term rates are an average of current and future short-term rates. Yeah, so this is the second assumption. So means that why is that? It's basically saying that, let's say long-term, we can take an example of like a very simple one, where long-term we just consider like for the next 2 years. So basically, the yield on the 2-year bond should be equal to the yield on the 1-year bond right now, and the yield on the 1-year bond 1 year from now, right? It's the same as you putting your money in the 2-year bond right now, means that your money will be locked there for at least 2 years. It's the same as you invest your money in the 1-year bond, then get back all your investment in the end of the first year, and then reinvest it again in the second year, and then in the end you should get more or less the same returns. So that's basically means there's no arbitrage in the market, right? So if the pure expectation theory is correct, you can use the yield curve to back out expected future interest rates. Yeah. Here is an example. This table here shows you the observed treasury rates and pure expectations. So you can see that the treasury rates are increasing along with the number of years in the maturity until 4 years old. Until 4 years. And then after that it's the same. 4 years and 5 years all share the same yield. So if the pure expectation theory holds, what does the market expect? What does the market expect will be the interest rate on 1-year securities 1 year from now, and 3-year securities 2 years from now. Yeah, so it's asking you to predict the future interest rate. The first one is the 1 year securities 1 year from now, and the other one is 3 year securities 2 years from now. So let's have a look at the first one, the 1 year interest rate 1 year from now. So basically it's asking you to calculate the 1 year forward rate. What we can do first is to draw a timeline like this, right? So right now we're investing money, and then this is the end of the first year, this is the end of the second year, right? So basically that you can do two investments. One is you invest your money in this 1 year security, get it back in the end of the first year, you get 6% rate of return, and then you invest all your money again to another security that returns X%, and then in the end your return should be the same as you invest your money directly to a 2 year security that returns 6.2%, right? Means that there's no arbitrage. So, but then you can write an equation like this. It's 1 plus 6.2% equals to 1.062. Then square, because 6.2% is the annual interest rate, and you invest it for two years, so we have to square. That equals to 1.06. This equals to 1 plus 6%. So your principal and rate of return the first year times X%. This equals to 1 plus the X%, right? So then you can restructure this equation a bit, and then you calculate the X should, in this case, should be 6.4%. Yeah, so basically this is it. And then the pure expectations theory says that 1 year securities will yield 6.4% 1 year from now. Notice if an arithmetic average is used, the answer is still very close. So means that here if we don't use time, we just average, then 6.2% will be equal to 6% plus X divided by Y number of years. And the test will be again 6.4%, which is very similar to 6.4004%. So in this case, it's actually very close, as it says here, because the numbers are relatively small and the number of years are even smaller. But it's not a big difference. Yeah. And then this one is calculating, basically it's the same structure, same question using different structures. This one asks what's the 2 year security, a 3 year security 2 years from now, right? So means that if the person wants to invest in a 5 year project, and then he has two ways. Either he invests his money in this 5 year product all at once and earns 6.5% every year, or he put in his money in these 2 year securities for 6.2% every year, and then invest the money again to another securities with X%. Yeah, so then you can write an equation like this, and then X will be equal to 6.7% in the end. Yeah, so the pure expectations theory says that 3 year securities will yield 6.7005% 2 years from now. Yeah, but I know that in the homework or in the quizzes, actually square probably is the most complicated calculations you can do on your phone. Once it becomes like 3 or 4 or even larger, it becomes very hard to clean it. So to calculate it. So basically, don't worry about this question, although I highlight it. I just want to use it to help you understand the pure expectation theory. But when it comes to quizzes or homework, I would at most ask you to calculate this one. Yeah, so it's 2 years maximum. It won't be more than 2 years. Okay, conclusions about the pure expectation theory. It's that someone would argue that MRP is not equal to 0. And hence the pure expectations theory is incorrect. Why is that? It's because if MRP is not equal to 0, which is actually what we usually see in reality, then in this case, people would prefer like short-term over long-term, right? Because long-term it involves higher uncertainty risk. So in this case, then you can't. These two investment won't be always the same. Like the one that we discussed before, the short-term investment should have the same rate of return as the long-term investment. So if people have preferences over the short-term than the long-term, then in this case, pure expectation theory won't be very accurate. And most evidence supports the general view that lenders prefer short-term securities and view long-term securities as riskier. Therefore, investors demand a premium to persuade them to hold long-term securities. In this case, MRP is larger than 0. Right? So that's the disadvantage or the drawback of the pure expectation theory. But that's not very important. You just need to, have a look at it. It's not. It won't show up in the quiz. And this slide, I will also skip it. This is the macroeconomic factors that influence interest rate levels. Basically, it's related to the factors that we discussed before about the inflation, about the productivity, about the risk, and etc. Time preferences. So I'll skip this part. The last part is some exercises. We can have a look at it together. So this one says, suppose a 1-year treasury bond yields 4% while a 2-year treasury bond yields 5.1%. Assuming the pure expectations theory is correct, and thus the maturity risk premium for a treasury bond is 0, and what's the yield on the 1-year treasury bond expected to be 1 year from now, right? So if we draw a timeline, I can't draw it here, but you can draw it yourself. Basically, this is exactly the same as the question that we discussed in slides, except the numbers are different. So if we draw a timeline, this is 4% is for the first year. The second year we don't know. So basically the 1 year treasury bond expected to be 1 year from now. So it's the second year. That's the one that we don't know. We say it's X. And then the 2-year is 5.1%. So what you can do is 1 plus 5.1%, then bracket square will be equal to 1 plus 4% times 1 plus X%. Then you can calculate X. So this is the equation I was talking about. Then you can calculate this X and you can know that it should be 6.2%. So the correct answer should be B. Yeah. And then the last question says, assume that the rate on the 1-year treasury bond, 1-year bond is now 6%, but all investors expect 1-year rates to be 7% 1 year from now, and then rise to 8% 2 years from now. Assume that also that the pure expectation theory holds, hence the maturity risk premium equal to 0. Which of the following statement is correct? So we can read through these options. Option A says the yield curve should be downward sloping with the rate on the 1-year bond at 6%. The rate on the 1-year bond is indeed at 6%, but you see the rate on the 1-year bond 1 year from now, so it means that for the second year or the next year is 7%, and then after that it's 8%. So basically it means that the interest rate is rising, right? So it cannot be a downward sloping curve. Therefore A is wrong. B says the interest rate today on the 2-year bond should be approximately 6%, very similar to C, which says 7%. D says 3-year bond should be 7%, and then or 8%. Okay, so we can actually have look at A, B, C, D, E together. Let's see, for a 2-year bond, the rate on the 2-year bond, actually, if the pure expectation theory hold, then this rate, so let's say 2-year bond is x, then 1 plus x square, bracket square, will be equal to 0.06, so 1 plus 6%, then times bracket 1 plus 7%, right? So in this case, the 2-year bond should be anywhere between the 6 and 7%. Yeah, so it shouldn't be 6%, neither should it be 7%. Should be in between. But for a 3-year, then basically that means, let's say the 3-year is, let's say, y. So 1 plus y, then in this case it's no longer square, but 3 times, and then will be equal to 1 plus 0.6, so 1 plus 6% bracket times 1 plus 7% bracket times 1 plus 8% bracket. Yeah. So in this case, we'll use the geometric average, but the 3-year bond should be in between, should be the geometric average of these 3 together, right? So it should be somewhere between 7% in the middle, right? So in this case, D is the correct answer. So that's the answer. Okay, so this is the end of chapter 6. Thank you all for attending today's class. I'll see you next time.